Let's take a, my goal for this is any of these that you need me to kind of help you out on, I'll help you out on. And then I'm going to go into 7.3, which again, 7.3 does a really nice job of tying together 7.1 and 7.2. And that's why I'm choosing to make the quiz happen on Monday. Okay? So first page, number 1 or number 2, is there any that you're kind of looking at that I can help you out with? Yeah. 2C. Okay, so what I'm going to do is I will go through all of number 2 just so we make sure we're okay with it. Okay, so it says a realtor wishes to find out the average value of homes in Golden Valley subdivision. The realtor conducts a search of 20 recent home sales in the neighborhood. The sample possesses an average value of 310, assuming that standard deviation of all homes in Golden Valley is somehow known to be $60,000. Let the sample size, okay, so things that we know. We have a sample of 20 homes, okay? So is the sample large enough? It's not large enough to be normal, so theoretically this is one of those where we probably should use our degrees of freedom. Hey guys. But we know n is equal to 20. So has random sampling been used here? So A, we have this. B, has random sampling been used? And the answer is no. Because you're looking at a neighborhood. These 20 homes sold, so now I'm going to collect the data from those 20 homes. So it's not a random sample. Okay, so no random sample was used there. Okay, C, construct a 90% confidence interval around the sample mean. Okay, so this is actually where I want to change up a little bit of where we've gone. So I was talking to another teacher, is Mr. T, and he said, if you show this method, everything else should start falling into place. And he showed a flow chart, which I'm like, dude, I loved it. Okay, so let me I'll come back to this question, but I want to hit this first. Okay, if you have a normal population, okay, somehow it's told you it's normal population, whatever. If I know if this is known, okay, what is that for? What does that mean? And I didn't say mean because I was meaning it's an average. What is it part of? What standard deviation? Is it the sample or is it the population? Okay, so this is the entire population standard deviation. Okay, so somehow you know that. So if this is known, if you know this, then you're going to use z-scores no matter what. Okay? So if you somehow know the entire population's standard deviation, no matter how many pieces of data you have, you're going to use the z-score. If this is no, okay, so if this is no, so I guess a yes goes down here. If this is a no, then we're going to ask, is the sample bigger than 30? If this is yes, we're also going to use a z-score. Okay? So, if we know the population standard deviation is a yes, we have it, it was given somehow, we're going to the z-score. If we don't know what the entire standard deviation is of the entire population, but I have a sample size larger than 30, we're also going to use the z-score. So it's the same exact path. if this is no, if I have less than 30, then I'm going to use the t-score. Okay? And this is all wiped out if it's not normal. So somehow you have to be able to justify, do I have a normal population? Okay? Do I know the entire population standard deviation? So it'll usually tell you that it's normally distributed. Okay? And that's where you have to assume they're telling the truth and not like being fictitious. So that normal things it'll say, you might see a problem that would say, hey, we want to find all of the SAT scores of all the kids in the state of Colorado. We know it's normally distributed. They tell you that it's normally distributed. And go from there. So, does that flow chart kind of make sense? Is there anything up there that's a little goofy? Okay, so this is where 7.1 and 7.2 are going to start tying together a little bit. Okay? So from there, let's go back to our last problem.
Could you split that?
Yeah.
Thank you.
Good thinking. Construct a 90% confidence interval around the sample mean. So the 90% confidence interval is going to say, am I going to use the score of Z or T? So using our flow chart, it says the realtor finds, is it normal? So no, it's not normal, but we're still going to go through it. B, has random sampling been used here? No, it hasn't been used here, but we still, for whatever reason, feel we should go through the problem. Okay? So construct a 90% confidence, God bless you, confidence interval. Okay? We want this. How big's our sample? 20. So theoretically, the problem's not normal, but we're going to continue through it. So should I use the z-score or the t-score for my equation? How much? Why? Yeah, being our sample is less than 20, we're going to the z-score. So, and again, I'm going to... did I say that right? They gave... Oh!
And it says all homes.
Oh, good call. Thank you. So we know, for some reason, we know that the entire population has this as a standard deviation. Okay? So, is the entire population known? Uh-huh. Do we know that? Uh-huh. So what are we going to use? Z-score. So we're going to use E is equal to Z. And remember, the Z is the only thing that's going to change on this over the standard deviation over sample size. Okay? So how do we get it? How do we find the Z-score of 90%? So two ways. I gave you the z-scores for 90, 95, and 99. But if we don't know the z-score, how do we go about it? Right, so what you have to look at is this. 90% of the area under the curve. Darn pen's off a smidge. So this region here and this region here are the same size. Agreed? The blue region in between should be 90%. So we're talking about 10% is left over. So this over here should be 5%, and this over here should be 5%. Still with me? So then I'm looking at this as 0.05. How do I find that z-score? Though I gave it, I've given to you on the table, so from the table on 7.1, this exists as 1.645. But if you didn't have that table to rely on, where am I going to get that z-score?
At the bottom of the t-scores.
Almost. What are some things that we know? What? That's for the t-table. And the reason we're not going to use the t-table for degrees of freedom, you're absolutely right to think that way. But because we somehow know the entire population of those homes, standard deviation, we're not going to go there. How do I find that z-score? What do we know on the calculator? There we go, inverse norm. Okay, so I want to show that we can get that 1.645 on the calculator. Just, I don't want you to think that it's some arbitrary value. So I'm going to clear this out. I'm going to go second bars. I'm going to go inverse norm. And on the inverse norm, what goes first? Percent? 0.05? Help me out if I'm not doing this right. What's next? The mean. Do we know the mean? What was the mean? 310. Thank you. 1, 0, 0, 0. And then what was the last thing that we put? 60,000, the standard deviation, right? All right, close that. Hit enter. Whoa, what did I do wrong? So is it inverse norm? Or is it not? Let's think about it. Or is it normal CDF? And I want to think about inverse norm. Oops, clear. This. Ah! What do you got? Inverse norm of just 0.05. Okay? There you go. All right, so two ways to look at the inverse norm. But the inverse norm, if you know you have a normal distributed item, what is the 211,308 giving you versus what is the negative 1.6445 roughly giving you? So all normal distributions should have a z-score of 5% to the left, being 1.645 standard deviations away from the average. So this negative value here, we assume it has to be positive. That's where this comes from. So I gave you this as far as the table for the 90th, the 95th, and the 99th percentile. But if you do the inverse norm of just the area you want, you're not necessarily worried about the mean and the standard deviation. Okay? What this value means right here is in order for a house to be in this area, to be in the lowest 5% of the homes sold, it has to be sold as a $211,308.78 home. But I'm not worried about what the home price should be. I'm worried about the inverse norm. The area to the left is how many, for 5% for normal distribution, is how many standard deviations to the left? It's negative 1.6445. For my z-score itself, I don't need it to be negative. Excuse me. But I just need to go from there. So let me bring this later. Okay. So I'm plugging this in, 1.645. I know I have the standard deviation of 60,000 over the square root of, what's n? And if you do that, that's going to yield you your E-score of what?
42,069.
So 22069.99, right? So that's what my E-score is. And in order to get the confidence interval, as I'm going to take the average, and I'm going to subtract it, I'm going to take the average and add it. So I'm going to take the average, which we know is 310. And I'm going to go this. And then the other part of it is going to be this added. Okay? Help me out. I don't. Oh, wait. I think I have it. Oh, I have it written here. Sweet. So then I get 287,930.01, comma 332,069.99. So I know that within 90% confidence, that's going to take place. Now, in order to do letter D, in order for me to do letter D, this is going to change. And that's going to change to, so right here, this will change to 2.576. Again, I can do the inverse norm on the calculator of 0.99, and it should give me negative 2.576, which means 0.5% of the area to the left, that smallest tail, is negative 2.576 standard deviations away from the normal average. Okay? And so if we do this, you're going to plug it in, and D would have gotten us to a little bit wider region. 9.34, comma, 34456.65. Okay? So why is the 99% confidence a larger range than the 90%? Yeah. The more confident I'm going to have, and I have to open up my viewing window. Okay? And then if your realtor said the average home sales in the neighborhood is really 350,000, do we have evidence to claim against this? So 350,000 is outside of our 99% certainty, our confidence interval for that. So it's so $350,000 house is outside of this. So is that a good statement made by the realtor? And the answer is no. Because it's outside of my confidence interval that I am 99% sure is going to take place again. 350 is to the right of it. Okay. Does that help you out on number 2?
Did you chase that dog too far around the tree?
Okay, 3, 4, 5, 6. Any of those? 6 E. Okay. I'll just run through the whole thing. Is that okay? So number 6. So it says, we wish to know the average income of all police officers in the United States. We randomly sample 20 officers from throughout the country. The average of our sample, so the average of our sample, so our mean is 57,100 with a standard deviation of 6,000. Okay? Okay, so first thing to do, we have a sample of 20 people. So let's put this through our test. So we wish to know the average income of all the police officers in the United States. I'd say you're basing off the United States, so it should have some sort of normal distribution to it. Okay? We randomly sampled 20 officers. So we're only talking about 20 people. Okay? So, a few things. Do I know the population deviation, standard deviation? Or do I know my sample standard deviation? It says the average of our sample is 57,100 with a standard deviation of 6,000. So being that sentence said, we have an average of our sample of this with this standard deviation, that tells me we have the sample standard deviation we're using. We're not using the entire population. Okay? So a few things take place. Is it normal? I'd say yes, we're trying to conduct all of the police officers throughout the nation. Do I have my standard deviation of the population known? No, I have the sample standard deviation, so I'm here. Is my value greater than 30 that I'm looking at? No, so I'm going to have to use my t-score because neither of these worked. I had a no here, and I had a no here. So I went no to no. So the path I'm following, that yes shouldn't be done. This is the path I'm following. Because I had the no's. Okay? What is it about this problem that tells you that to use a t-distribution and not a z-distribution? So we know that we are using less than 30. That's our first clue. And they give us the sample population. These are the two clues to tell us use t. And if I use t, that means I'm using degrees of freedom. I'm using the chart in the back in order to get there. Okay? So we are going to create a 95% confidence interval for this. Okay? I'm not going to use the calculator on this one. I'm going to use the t-table in the back. So think about it. We want to create a 95% confidence interval. So 95% means that the two tails at the either side account for 5%. So each tail is 2.5%. Are you still with me? And 2.5% of the true decimal is 0.025, right? 0.025. My degrees of freedom are what? Degrees of freedom are what? 19. So 19 is my degrees of freedom. I'm using 0.025, so it looks like I get 2.093.
Should be 29. Oh, no, and it's 20.
And it's 20. So your degrees of freedom is one less than your sample size. Did that answer your question? Okay. So, again, we're going to go back to this equation here. This equation, but this is not going to be z. It's going to be what? T. So I'm going to use E is equal to T times the standard deviation over N. Okay? But what is this standard deviation here got to be? We're choosing to use T because we don't have what standard deviation? Which standard deviation do I have? I have the what? The sample size standard deviation. Okay, so I have to use the sample size standard deviation as the standard deviation given. So T is this. So I have, that's supposed to be an E equals 2.093 times my sample standard deviation 6,000 over my sample size, which is 20. And if I work that, I should get so 28 E equals 2808.5. So my confidence interval is this. Which is going to give me this, roughly. I think we rounded on our answer. Okay? Based on this confidence interval, do we have evidence to claim that the actual annual price or salary of police officers nationwide is $45,000? So I can say with 95% confidence, if I reduplicated this survey, I'm going to fall within that. Now they want to ask, hey, is 45,000 something that we can actually focus on here? So my thing is 95% confident. Look how far that 45,000 is outside 95% confident. 99% confident might get us a little closer to this, but we're still outside the interval. Okay? And then it says create a 99% interval, so it's kind of goofy that they went that way. But if you create a 99% interval, so the 99%, and I'll just put it without going through the work, we go 53, 362, and 60, 938. So again, that's even more reinforcement to say 45,000 cannot be thought as the actual annual salary. Okay, because now we're 99% confident, it's still outside of it. And then if you created a confidence interval of 99%, so if you did the 99% confidence interval, so this is letter E, but we're changing our sample to this, what should we use then? We're changing our sample to 200. So, normal, yes. Do we know the entire population standard deviation, or do we know the sample standard deviation? We know the sample, so it's no. Is our sample going to be bigger than 30? Yes. So what do I use then? The z-score. So this is good because this is larger. So I have the sample standard deviation we know, but we're getting up to 200. This says all over it, hey, use the z-score rather than the t-table, which means you're going to have z equals standard deviation over the sample. And then if you go and find 99%, so remember inverse norm of 0.99, close parentheses, or you just can know from the table that your z-score that you're going to use is 2.576, which is going to give me 2.576 times the standard deviation of the problem, let's give it 6,000, and that's going to be divided by the square root of 200, and this one is going to show us that we get 1092.9, which means we get to 5607.10 and 58,192.9. And that is what the review was. Okay, so clear as a cream pie? Okay, so let me just rehash this one last time. Okay, I want to go through this so you feel comfortable with it. And what I would do is you don't really have a note page, so I think the green page in the back of the book, let's put this flow chart. Okay? So we know it's a normal distribution. If we know this is the entire population standard deviation, okay, if we know all of that, so if this is yes, z-score. Okay? If this is no, then we're looking at our sample size. And if our sample size is greater than or equal to 30, so if this is a yes, z-score one more time. If both are no, we go to t-score. And all of those relate to E equals Z times, don't do that. Z times the standard deviation over the sample, or, come So those are going to be related to it. So guys and girls, that right there, though I didn't work through the examples, is 7.3. And let me go to 7.3 real quick. Take a look. Let's have you guys and girls for homework let's have you do the 7.3 worksheet. So let's have you work on number 1 and number 2 on 7.3. Is that okay? So number 1 and number 2 only for Monday. We'll go over that. We'll also quiz on Monday. Got it? Sound good? You feel a little bit better about this? Does the flow chart look well?
Yeah.
That's thanks to Mr. T. He said, dude, show it this way. I was like, oh. One thing you have to know about teachers is we beg, borrow, and steal all the time. And the most important thing I want you to get out of today is what?
Be excellent to each other.
Yeah, be excellent. Bill and Ted, be excellent to each other. Take care of one another. Guys and girls, I can't tell you. You see that kid that you might not know, and you see that they're kind of just slumping there. That smile, that, hey, how you doing? That's, hey, good to see you today. Or you know what? Let them know that something that they're wearing looks really good. Hey, those are awesome shoes. Hey, I like your shirt. Hey, that looks good. I don't care if it looks like crap or not. Why? Okay? Take care of one another, and as Bill and Ted said, be excellent to one another. You know that movie Bill and Ted was